All right. So in 12.3, we're continuing essentially with yesterday's lesson. So who can remind me of the two different situations where we get a unique triangle? There's only one way to make the triangle. I might be able to rotate, reflect, translate. I might be able to make it look different, but there's only actually one triangle. It was on the back bottom of yesterday's notes. Don't look at it yet, but that's where it was.
Oh, wait.
No, like what are you given? When you're given, Brennan? Two, do you say 2 or 3? 2. So 2 sides. That has to then have an and. What kind of angle?
90 degrees.
Not 90. I mean, it could be 90.
45.
The size of it doesn't matter.
180.
You don't really have space on your notes. Guys, if you fail, what angle?
Right angle.
Is it?
I feel like I'm wrong, but now any angle?
Nope.
An acute angle?
Is it the included or the not included angle?
Included.
The included. So, given 2 sides and an included angle, we only get one possible triangle. The other situation where we get one possible triangle is if I'm given, y'all come in here. Was that, I think that was Isaiah just said, if you're given all 3 sides, there's only one possible triangle. Now what about when we get multiple options? There's actually a bunch of situations where we get multiple. If I'm only given one side, then of course there's going to be a bunch. If I'm given 2 sides and a not included angle, so say I'm given this side length of, let's say, x, this side length of y, and then this angle here, there are actually multiple possible. Of course, that would have to be an acute. But depending on how I pivot my x side, I could have multiple representations of that triangle. So just remember that you get a unique if you are given 3 sides or 2 sides and an included angle. That included angle is really important there because it has to be between your 2 sides. So we're going back to our science store.
I need something triangular, but I can't wait while you make them. If you can pass a test on angles, I'll leave all the information and pick them up later.
I accept your challenge.
Except. Oh, you're lame. So, sine 1 has angle measures 45, 45, 100. Sine 2 has angle measures 30, 60, 90. So when we look at these 2 sines, let's just analyze for a minute. What rules about triangles have to be true? Luke? Yeah, any 2 sides have to be bigger than the third, but we don't know anything about the sides here. So that rule is not really going to help me in this situation. Brianna? The sum of the angles has to equal 180. Write down somewhere, angles must sum to 180, or angles must, yeah, let's put sum because that means the total when you add. What was that? The first one is 190. So can that happen? No. So sine 1 can't be made. Its angles add up to 190. So if you add your 45, your 45, and your 100, you get 190, and that is not a triangle. The second one, being 30, 60, 90, can be a triangle. So if it has sides of angles of 30, 60, 90, that's going to determine my side lengths. But because we're just trying to label the angle measures, we'll leave the side lengths alone. So what we know is any side opposite a small angle will be a small side. Any side opposite a big angle will be a big side. So I'm going to draw my short side vertically, then a little bit longer of a side horizontally, and make my 90-degree angle between them. And then my longest side will be my hypotenuse. And I would have to label that this angle in here is 30 degrees. This angle in here is 60 degrees. And we see the 90-degree angle based off the box. So if you used your protractor, we could, I wonder if that has anything to do with that. If you use your protractor, we can make that perfect, but then we'd have to be very careful with the side lengths. Big thing I want you to see here is my biggest angle is opposite my biggest side. My smallest angle is opposite or across from my smallest side. And guys, this is the very basic beginnings of trigonometry. Trigonometry is where we use, if you look at your calculator, if you've ever noticed on the TI-30s, it says sin, cos, tan. That's actually sine, cosine, and tangent. Those are trig functions, and you'll start using those next year to determine things about triangles.
Are you recording?
Yes, I am now. At least I think I hit start. I sure think I hit start. I hope yep, I'm recording. Hi, YouTube.
What's up, guys?
All right, any questions on this one? First thing you always want to check when you're given all three angles is, can this even be made? All right, so moving on to part one. Can we make a triangle that has angles of 60, 60, 60? Yeah, that 60 plus 60 plus 60 adds up to 180. We know this can be made. Now, if all of my angles are the same size, what's that tell me about my sides? Cassidy? The sides have to be equal. If all angles are equal, all sides have to be equal. So what kind of triangle is this going to make? An equilateral triangle. So somewhere write down that this is going to be an equilateral triangle because we see all three of these angles are the same. So with your ruler, choose your side length size. I'd make it something easy that fits in that space, like maybe 1 inch. Now here's my question. When I know all three side lengths, I can only make one triangle. What if I know all three angles? Can I make multiple triangles here? Or am I locked into only one size, one straight up triangle? Was that a 1 or was that a hand? Alright, guess I'm going to have to call on people. What do we think? Am I locked into one unique triangle or could I make multiple? Thomas?
I think you can only make one because if you try to change it, it'll change the angles.
Okay.
Maybe you could make it bigger or smaller as long as it's still 60 degrees.
So if I make my side lengths bigger or smaller, will that necessarily change the angles? That's the question here. Guys, can we stop with like making noise just to make noise? It's really annoying. So I'm going to start with a small side. I'm going to move my protractor over, set it up to get my 60-degree angle on the one corner. So then I drag my other side over. I take it from that vertex to my 60. Then I drag my protractor over to my other corner, check my 60, which now I'm coming up the other side of the protractor, drag my side over, or you guys would be drawing, not dragging. And when I connect these, although this is kind of messy because it's all on top of each other, I have that this angle's 60, this angle's 60, and this angle's 60. To show that they're all the same, we can just use a tick mark. So So I can put a tick mark here, a tick mark there, and a tick mark there. Shows those are all equal angles. But now what if I choose a bigger side, like this blue side? Could I still make a 60-degree angle off the vertex of that line? Yeah. So I can drag this over, plop it right here, drag another side, set it to the 60 degrees from that vertex. And I do the same thing from the other side. Oh, come on. Going to do the same thing from the other side, but I know that if I made my first angle correct, then to connect these two must be 60 degrees. And again, all of these angles are the same, so I can mark it there, there, and there, all with tick marks. So wait a minute. I just made two different triangles, both with 60 degrees in every single corner. Could I use my bigger line here and make another triangle?
Yeah.
Could I take like boards that are all 8 feet long and make another triangle that has 60, 60, 60? Mm-hmm. So the rule that we want to write down here is when given 3 angles, there we go. Given 3 angles, how many triangles could we make? Yeah, we could make infinitely many triangles. Now, what if I was given 3 angles and told a side length? Then how many triangles would I be able to make?
Just that one.
Yeah, if somebody said, hey, all of your angles have to be 60 and you have to use the blue line, I could have only made 1 triangle. So once they introduce side lengths, that's when I start to kind of get constricted, when I have limits put on. So try this. You can do any lengths you want. I just want multiple triangles with angles of 30, 150. Now my advice is start with your bigger angle. So I would draw a line, always start with your bottom. And then either on the right or the left side of that line, make one of your angles. I suggest making your 100-degree angle first. Remember that your shortest side will be across from your smallest angle. Your longest side will be across from your biggest angle. This gets somewhat difficult. You will end up having to probably erase some extra. So here, actually, I'll help you with this one because you'll probably struggle, at least on the first one that you do. When I draw my line on the bottom, I'm going to go ahead and say that length is going to stay that length. Then I'm going to draw my 100-degree angle, but I'm going to go really far with it. Then, over from my other end, since I've used my 100, that's checked off. What could I put at this vertex? I could put the 50, or I could put the 30. So if I put the 30 over here, I'd measure my 30 degrees, and then wherever this hits, I now erase the extra line that I drew. If I had done the 50 degrees, the only difference would be that my 50 degrees would have opened a little bit bigger and it would have hit a little higher up. Now, of course, I'm not measuring perfect angles because I don't have a protractor on this problem. then to make a different, well, I've already made two different triangles. So really we would want to draw them separately, but that's how I do two different triangles. I could either do 30 over here or 50 over here, depending on how I want these to connect, keeping my 100 degrees down here. So that's how we draw two different triangles when given all three angles. Is you set your base, put one angle on the one side, put the other angle on the other side of it. I'm going to talk you through the method that you need to avoid. Well, okay. Not that you need to avoid, it's just a little bit harder. Let's say I drew my bottom line, and then I put an angle, so I draw my bottom line, I make my 100-degree angle, and then I decide I'm going to put a vertex right here. So I'm going to erase this, and I'm going to make my angle off of this line. I could do a 30-degree or a 50-degree angle off that vertex, but depending on how long I made my base, this is why I say it might give you some issues. Let's say I made my base short, and then I go to do, let's say a 50. I'm just trying to approximate here, but 50 would maybe be like this. I come down here and I have no line. So what would I need to do? I would need to extend my base. I don't know who said it, but I heard it from somewhere. So I would need to go back and say, okay, base, you're actually going to be longer than I originally thought. I need you to come out here and meet up with that other side. So that's why I suggest starting two angles off that base side. Because if you know the base side and you put both your angles off of there, it'll make your job easier. And always draw extra, then come back and erase. Always draw extra, come back and erase. So we've already pretty much answered this, but to put the answer in a nice, concise method, chapter... So here on your notes, where it says if you form a triangle given three angle measures, I would like you to underline, highlight something, your three angle measures. Three given angle measures. How many triangles can we make?
More than one triangle.
More than one. So many, really. We can make a whole lot. Yeah, really infinitely many. But since infinite is a hard concept, we just say we can make a lot. We can make many. Huh?
It never ends.
Think of the biggest number possible. Then take it to the power of the biggest number possible. Then multiply that number by the biggest number possible. And then add the biggest number. You see what I mean? Like, we could keep getting bigger, 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 big. Like, we can always keep getting bigger. Here's another idea. I forget what it's called. I want to say Kepler, but I think it's wrong. We have a space probe that we launched. It's a nuclear space probe. So it runs off nuclear energy, so it doesn't need to, like, doesn't need any other energy. It, like, makes its own energy. It has been heading away from the Earth since the 80s, maybe 90s. I forget when we launched it. Sometime I was either not born or I was very, very young. It has been going in a straight line since then. It will be going in a straight line, hypothetically, forever. So that space probe will end up infinitely far away, but it's going to keep getting further away. So we can't ever actually say how far it is because it keeps getting bigger. Does that make sense? Like, that's where the idea of infinity is kind of difficult.
Mr. Hudson, have we seen any new planets off of the probe?
Yeah.
It just reached Pluto.
What?
Like, that's how long it takes to get to Pluto. It just passed Pluto.
Yeah, they like get their first picture of Pluto.
Yeah, I think it's finally back. All right, so we're looking at pennants, a school pennant. This is why I pulled this off the wall and then it never got back on the wall. school pennants like this. A lot of schools have pennants. You put them up on your wall, and you're like, I went to this school.
Isn't
Yeah, so
that, what's it called?
that's where I went to school.
Is that where,
Miss McGorian goes.
Yeah.
Yeah, that's where she goes as well. Yeah, Miss McGorian goes to Otterbein. That's we knew each other before she actually came here.
Isn't that down in West?
Well, downtown's kind of relative, but yeah, it's in Westerville.
Isn't it uptown?
It is in Western.
Kind of, yeah. Westerville calls it uptown.
All
All right. So, a school is selling pennants, triangular-shaped signs. Here's the given information that we have. 2 angles measure 65 degrees, and the included side. Highlight this. What does it mean for the side to be included? Between what?
Angles.
What angles?
Lines.
Between the...
Inside angles.
That side has to be between these 2 angles of 65 degrees. If it's included, it's between the 2 things we know. So since the side's included, it's got to be between the 65s. So, is this enough information to be sure all the pennants are the same? So, instead of 12 inches, I don't know if I scaled this right on the paper. Try to measure and see if you can determine, are all these signs, are all these pennants the same? Or are they actually different? So we have 2 angles and the included side. 2 angles and the included side. What do you think? Are they all the same? Or are they going to be different? So think about it like this. I know this is not like the same size, but what if I gave you the angle down here, and the side length between them? Will that determine the rest of my triangle? Will that determine where those lines meet up here? Or could these lines maybe meet somewhere else? So what do you think? If I know this side and both angles around it, could I make multiple different versions of this? What do you think? Are these triangles different, or do they just look different? Because I can turn this. I can make it look different. Oriana?
They're the same.
They're the same?
Yeah.
You certain?
Yes,
No.
turn your head. Wait.
Oh, I wish it showed it up. They're the same.
Yeah, they
When you're given 2 pieces of information and another included piece of information, that locks you in to only having, actually I'll pull it up and I'm going to breeze through this really fast. So notice that all of these have the 12 between the 2 65s, which means that point where they meet, these lines as they go have to follow the same path the whole time. So where they meet is not going to be random. It cannot change. It has to be right there. Same thing when I come off of F and come off of E, I have to meet at D. When I come away from H and away from I, they have to meet at G. They're all the same shape. So I would jot down somewhere like below that on your notes, 2 angles and included side equal unique.
2 angles what?
And an included side. Sorry, that's an and. I can't really make an ampersand. I've tried many times. Well, not many times. So the ampersand, we discussed this in one class yesterday. The ampersand is your and. So I just always try to make it backwards. It's like that.
I just do like a line.
That kind of looks like an A.
And then a line. Cursive X.
Yeah.
I don't know why.
2 angles and an included side equals unique. Yeah.
If we already wrote this somewhere else, we have to write it.
No, that's fine. Yeah, if you already wrote it somewhere, that's fine. Flip to the back. So now you're given that we're going to make triangle ABC. We always like starting at the beginning of the alphabet. I know how could I call these angles? If I want to make these angles a little bit simpler, what vertex will angle ABC be at? At what vertex will ABC be at? Will it be at vertex A, or vertex B, or vertex C? At B, right? So this is really angle B. What angle is this 80? That's really angle C. They're using 3-point notation just to make it a little bit more clear, but we wouldn't have to. Thomas, you should be writing. You should not be spinning. So the question you have to ask yourself is the side that I've been given included or not included? Oh, by the way, I wanted to point out, I'm going to do this on the chalkboard, so I'm going to leave it here all day. When we have a segment, say we've got a segment from B to C, like they're talking about here. And we know that it is size, let's just go ahead and say 10. When we talk about that, and I write BC, this is not segment notation. A lot of you on your mastery that I just gave back wrote segment notation next to number 1. What do I need to show that it's a segment? Eli, you had raised your hand. You have to put a line over the top of it. So you might want to pull your, or at the end of class, you might want to pull your mastery back out. A lot of you, that's all you missed for a segment, like for saying what the radius was. So we would say BC is 10. This is one of the areas where I don't like Pearson because they don't put the line above the BC. It's kind of hard to do that probably with the software they were using. It like didn't work out very easy. But we should have the line above this. So go ahead and put a line above any segment we work with. Draw the line above it. I did not think to go over that. I didn't realize that a lot of you would not know that because Pearson doesn't put it in there. So please make sure you pay attention. If we're notating segments, they've got to have the line over top. So is segment BC included between the two angles that I know, or is it not between the two angles that I know? Katie, what do you think? So we're having difficulties with this, right? Let's try to sketch this out. Start with the side that you know, BC. So don't measure this. We're just going to try to approximate. This would be B, and this would be C. It tells me angle ABC is 35, which means that's actually angle B. So if I try to approximate 35, it's going to be an acute angle. As long as your drawing's close, I don't need these things to be perfect, but I need you to have an understanding of size. 35 is acute. It's less than half of a 90. So if I think about, okay, a 90 would be right here. Half of a 90 would be right there. 35 is just under half of a 90. Does that make sense? Then angle C, or angle ACB, we're told is 80. Now, do I know anything about this side that I just made, by the way? Do I know where it ends? No, so I should really either dotted line or solid line continue this out to say it might be longer. It may not stop there. I don't know where it stops. So now I go look at ACB. Well, that would really be this corner. And if that has to be 80 degrees, again, think about, well, my 90 would be straight down. So 80 will be slightly less than that, so slightly acute. So this would be 80. So then I need to continue my line until where it meets. I can erase my extra lines. Is the side that they gave me of 10 included? Yeah, that's where that glitchy spot on my smartboard is, guys. Sorry about that. It just looks bad. Is that side included between the angles that I know? Eli?
I forgot what included meant.
Well, can somebody remind Eli of what included means?
Between
Karina?
two things we know.
Between two things we know. And really, things needs to be a bit more accurate. If I'm looking for an included side, it's got to be between angles I know. If I'm looking for an included angle, it has to be between sides that I know. Is this side that I know between two angles that I know? Yes, this side is between the two angles that I know the size of. This makes me a unique triangle. Sorry, that E kind of looks weird. This makes a unique triangle. Do I know my third angle?
You don't know, but you can find it out.
That's why I wasn't gonna let you think about that for a second. Do I know my third angle? Nobody gave it to
Wait, no,
me.
angle is the A, right? Like,
Yeah, the third angle is going to be angle A, my last vertex up here. So what I'm saying is, do we know what this is? Well, nobody told it to me, but how do we figure it out? Luke? No, don't just measure it. I can do it algebraically.
Oh, you could do
add
80
and 35 and subtract it by 180, which is 75.
So, don't write right here, right wherever you have space, but angle A will be 180 degrees minus the other two angles. So we do 35 plus 80. That really becomes 180 minus 115. So angle A must be, you said 65?
Yeah. When I measured it, it was 6.
So that's why we have to be careful measuring. When we draw it, our measurements will get slightly off. That's why we want to solve it algebraically if we can. And we find out that's 65 degrees. So now I actually know 3 angles and a side. And guys, if I know 3 angles, will my side be included? It has to be.
Included, but
Let's say they gave me the other side, AC. It's now included because I now figured out angle A. So when they give you 2 angles and a side length, you can solve the third angle, and then no matter what, your side is included. So when they give me 2 angles and a side length, if that side's included, I know that I can solve it, and then know all 3 of them. Any questions before we move on? So if we form a triangle given 2 angle measures and a length of an included side, we already wrote this down, right?
Yeah.
2 angles and an included, I think we did it right up here. 2 angles and an included side. So this you should already have that this is unique, but if you want to write it down again, you can. It will give you, or unique / more than 1. Or sorry, unique only 1.
Dang it.
That's good.
What's a net? Not like what you fish with, but mathematically, what's a net? Isaiah, we haven't really talked today.
It's like if you take a 3D object and you unfold it, it'll be all those spaces.
Yeah, if we take a 3D object and unfold it. So like if I took the net of this coffee cup, forget about the handle. If I took the net of this coffee cup, I have the bottom would be what kind of shape? A circle. And then if I think about cutting this, let's imagine this was plastic. I could fold it, maneuver. If I cut this down and unroll it, what kind of shape would it be?
It would be like
A rectangle, right?
like
So-
rectangles, but round on it.
it looked like a division.
No, so this would really end up as a rectangle with a circle. Now, if it had a circle at the top, then I'd have another circle, but I don't. So I really just have the rectangle for the cup around and then the circle for the bottom. But
Wouldn't the circle really be anywhere on that bottom
yeah.
side?
So we're assembling a cardboard net to fold up into a box that has a shape of a square pyramid. What makes a pyramid square? What part of it has to be square? The bottom, right? So the Egyptian pyramids, are those square pyramids? Yeah, because they have 4 sides as they go up. They have 4 edges at the bottom. They're square at the bottom. You start with the parts that we have shown right here. CD on my square is 5 units because it's a square-based pyramid. So do I only know one edge of the square? They only give me one edge. But we know all of them because they have to be the same. So then it says, can you be sure that you can make all of the other triangle pieces the same size as the given triangle? Now the only other thing they give me is that FEG is 44. EG, now this is a little hard to see, so I'm going to go back to digits because my page there's a little bit hard to see. So they've now given me a couple angles and a side length. So we know FEG, or really angle E. So on your paper label, this is the 44. EGF is really angle G. So this angle is the 68.
But we don't know.
We don't know the
Yeah,
Isn't the second one?
We don't know, but you would
What,
say
Oriana?
68. I said we could figure it out pretty easily.
We can figure out angle F pretty easily, Oriana says. Angle F is going to have to be the last part of the problem to add my triangle up to 180. So, Karina, what do we do?
You do that. You add the 68 and the 44, and you subtract that by 180.
Yeah, but you said the subtraction count. You subtract.
44 from 60.
Yeah.
That.
Well, no, maybe you said that right. Yeah, because you said add it up, then subtract that from 180. Yeah, that was right. So 68 plus 44, the sum of those angles, well, 60 and 40, first off, gives me 100. 8 and 4 gives me 12 more. So this is really 112.
68.
So my 180 minus 112, and then we get 68. So wait a minute. If angle F is also 68, what kind of triangle is this?
it's an acute triangle.
Well, yes, but more specifically, it's isosceles.
I thought that's what you said.
Two S equals 2 sides.
All sides are not.
So, if we know that E is going to be the tip of my pyramid, where would this side length of CD, where would this side length relate on the triangle? Where would that side length relate on the triangle?
Whoa,
So what we have here is this. They've given you the square for the bottom. We know that the edges are 5. They've also given you a triangle. You can look at just that triangle. We know that this top angle is E. This angle is F. This angle is G. But notice that the triangle attaches to the square. So if the edge length of the square is 5, that also tells me that the bottom edge of my triangle is 5. So now I know the length of an edge in between two angles that I know. Do I have enough information to make sure they'll be unique triangles? I have a side included between two angles, so I do. I know everything that I have to know. We are not quite done, so we will probably wrap up the last couple questions. Notice, hey, before you get out of here, same as yesterday, your cheat sheet is on the bottom of here. When you get a unique triangle, those situations, or more than one triangle, those situations. Thank you very much.
And then